Good afternoon everyone. In this video we are going to discuss about root locus. So normally the root locus is used to find the stability of the system and the relative stability of the system. It can be used root locus. So in this video we are going to discuss about the what are all the steps involved in the root locus. Okay, there are 9 steps involved in the root locus. The first rule is the root locus is symmetric about it in the real axis. That is the first rule. So normal root locus is symmetric about its real axis. Then rule 2, the each branch of the root locus originate from open loop pole corresponding to k is equal to 0 and terminates either on a finite open loop 0 or open loop 0 at infinity corresponding to k is equal to infinity. The number of branches of the root locus, so terminating on infinity, is equal to n minus m. So the number of open loop poles minus the number of finite zero. So normally in the second step what we are going to do, we are going to find the number of poles and number of zero. Whichever things it comes in the denominator, that is the poles in the transfer function equation. Whichever things comes in the denominator, that is pole. Whichever things it will become related to s term, that is the zeros in the transfer function. Okay, so here number of poles greater than number of zero, then it will starts from the zero in your graph. Okay, suppose number of zeros it's greater than the number of poles, it terminates from infinity. Okay, so this is you have to remember over in this rule 2. Okay, so normally in the rule 2 we are going to find the number of poles and number of mm, zeros. Okay, normally number of poles we are going to mark as m, as well as number of the number of poles we are going to mark as n is equal to n, and number of zeros we are going to mark as m, indicate as a m. Okay, same poles, number of poles p is equal to, like, we are going to take it over there. So then rule 3 is the segments of a real axis having odd number of real axis on open loop poles plus zeros, they are right or part of the root locus. Suppose if we are going to take from the divisions, so from the particular divisions to right side, how many poles and zeros are there, that we are going to take. So number of poles and zeros, it is in the odd number. Okay, so that area is in the part of root locus. Suppose that is the even number, it is not in the part of root locus. So that is the part you should have to remember over here. Then next rule, it is the we are going to find the angle, that is asymptotes. The n minus m root locus branches tend to infinity. So along a straight line, asymptotes making angles with real axis given by asymptotes, we are going to find the plus or minus 180 degree into 2 cube plus 1, so divided by n minus m. So already I told you n minus m, n is the number of poles, m is the number of zeros. Okay, so n minus m is equal to, we can write it as in the cube. Suppose n is equal n minus m 3 means we are going to write q is equal to 0 comma 1 comma 2. So like this we are going to find the angles over. So that will becomes in the rule 4 or step 4 in the this root locus. So then comes into find the centroid, the main thing. And before that, the poles and zeros, how we are going to mark over in the this one root locus. The poles always we are going to make it in the cross mark over in the real axis, and this one zeros we are going to mark in the circle. Okay, then comes into the finding the centroid, that is the formula is the sum of poles minus sum of zeros divided by n minus m. So number of sum of poles, so how many, suppose 2 3 4 means 2 plus 3 plus 4. Okay, total number pole 3 poles, so that 3 it will become, sorry, sum of zeros. Suppose only 2 zeros is come means 2 1 plus 2 means, so 3. Okay, divided by here n minus 2, 3 minus 2. So like this it will becomes over here. So from that we are going to find the centroid. After finding the centroid, we are going to mark is in the square mark over in the exactly the particular centroid point. Okay, that indicates the centroid of the system. Then comes into the next thing. After making the centroid, there we are going to make the angles. What are the angles we are going to find? That we are going to draw with the centroid only. Okay, then rule 6, we are going to find the breakaway and break-in points of the. So breakaway and break-in points of the root locus are determined from the roots of the equation dk by ds is equal to 0. So if number of, that means first order differential equation. So if r number branches and root locus meet at a point, then the breakaway angle is plus or minus 180 degree by r. Okay, so this is the rule 6. Then comes into the next one, rule 6, the angle of departure from complex open loop pole. Suppose if the complex open pole they given, we are going to find the angle of departure or angle of arrival. Okay, if suppose there is no complex pole, they are not given, there is no need to find the this angle of departure. Okay, so qp is equal to plus or minus 180 degree into t cube plus 1 plus pi. Yeah, so here q is equal to 0 comma 1 2. So this is the formula to find the angle of departure. So where pi is the net angle contribution at the pole by all other open loop poles and 0. Similarly, the angle arrival at a complex open loop 0 is given by pi z is plus or minus 180 degree into 2 q plus 1 plus pi. So q is equal to 0 comma 1 2. So here pi is the net angle contribution at the 0 by all other open loop and poles 0. Then comes into the next one, next rule, the intersection. The intersection of the root locus branches with imaginary axis can be determined by use of root criterion or by letting s is equal to j omega in the characteristic equation. So wherever the s comes, so there and all we are going to put the j omega term. Okay, in the characteristic equation. After that, we are going to equate the real part and imaginary part into the 0. Okay, so what is the real part? Wherever the j term is not coming, that is the real part. Wherever the j term is coming, that is the imaginary part. So like this, we should have to do solve this problem. Okay, so here to solve for the for omega and k, so the value of omega intersection point imaginary axis and k is the value of gain of the intersection point. Okay, so omega is the intersection point of imaginary axis, k is the value of gain of the intersection point. Okay, so this is the point you should remember over here. Then find the open loop gain k. So at point s is equal to sa on the root locus is given by k is equal to pi of I is equal to 1 to n and modulus of sa plus pi divided by pi into I is equal to 1 to m and modulus of sa plus zi. So it equal to product of vector lengths from open poles of the point sa divided by product of vector lengths from the open loop zeros to the point sa. Okay, from this, so normally here we are going to find the two case. So this is the open loop gain k is finally we are going to find. So this k with going to find the uh, real value, real part value. Okay, so should not confuse in this. So like this, there are 9 rules. So after applying these 9 rules, we are going to plot into the graphs. Okay, so in the graph, first initially we are going to mark the poles and zeros. After that, we are going to find the root locus. So after finding the root locus, whichever comes in the root locus, that will be make it as a dark line. On the dark line and another the next step, we are going to mark the centroid. From the centroid to draw the angle. After that, we are going to find the break and breakaway point. After finding the break and breakaway point, this s value are going to mark over here, and from imaginary values also we are going to mark over in the graph. So all the 3 points we are going to join over here. Okay, so after that, Now after 3 points we're going to mark, suppose any limit z value they are given, we're going to find the z value. Okay, like this way we are going to do the uh, root locus over here, like these steps. So that we are going to discuss over in the coming classes with the help of the problem. This is about the root locus steps. Okay.